administrative processing. Then I had to prepare my semester proposal.
Like that?
Yeah.
So,
Very important.
Do you have
Yeah.
sign up though?
What? You didn't give it to me. Bro, I told you. No. You told me once. And I was like, no, you were hiding it from me. That's my second story.
Ready? All right, so we're gonna get started. Basically today, you asked a great question. What we're learning about. We're gonna be learning about hacking Linux and web apps. And yeah, you'll be like, look, mom, I'm an elite hacker. So you'll look like that once you finish the lecture today. So also to like preface, this is gonna be a shit ton of content. So if you have any questions at all, please ask, because it's a lot of stuff to take in. So yeah. Okay, so a quick little recap about Linux. So remember when we talked about Linux like 2-3
Nasir, can you make him host?
Oh yeah, maybe host too.
Yeah. Just the ID. I will call the video, and then the password will be your password.
Just make him maybe sole host or co-host.
Just host. Yeah.
Wait, really quick, because I'm looking at the responses right now. So like we track your attendance because that's like part of your like, grade. So if you didn't do attendance, I only see 6 responses. Can you guys like go do it right now?
That's what that form is for.
Yeah.
Yeah.
Oh no, if you didn't do it.
Yeah, I'll give it like a minute. Also, I'm gonna redo the slide again because it died. So yeah, deja vu.
For this meeting, we're gonna upload we're gonna try to upload the recording as quick as possible because like so you'll see when you get to the like material, but it's like really dense. So you'll probably be looking back at the slide or at the recording and like looking back what Bryce said. So yeah. Everyone have the link?
Okay, cool. So I'm gonna pretend nothing happened. Yeah, okay. So we're gonna be teaching about hacking Linux and web apps. That's gonna be you in like an hour and a half, elite hacker. But yeah, again, really quickly. So for Linux, basically it's hosting. So Linux, when you see it out in the open, out in the web, it's gonna be most likely being a server. You can have it on a laptop like a workstation, but for the most part, you'll see it as a server. So its main point of use is that it's hosting some sort of application. So websites, databases, stuff like that. And us as penetration testers, we want to go and try to hack into these Linux servers. And the way we'll be doing that is the services that they're hosting, because that's the main way in. And basically you'll be exploiting that through, it's either like vulnerable because it's old, you'll be finding some sort of like web vulnerability, which we're talking about a lot today. And once you get access to that, basically that's called like getting a shell. And the reason why they say that is because when you get terminal access to something, like on the server, they just say it's like a shell basically. So if you ever hear me say, oh, you got a shell, that means you basically got access to the server. Okay. Cool. Okay. So for the most part, before we even start trying to go and hack into something, we need to go and gather more information. Information is key. Don't ever just jump into something like, oh, I ran something. I think I see a way in and just jump straight for it. Try to get as much information as possible. And the thing I like to call this is like triaging. So if you don't know like the word triage, think of like a hospital, right? Let's assume that you're a doctor and you see 20 patients, they all came in at the same time. And you need to go identify who's the one who's going to die the soonest, right? You need to go and help them as fast as possible. So what you need to do is basically get as much information as possible, look through all of them and try to diagnose like basically which one looks the most vulnerable, which one looks like the most like interesting. If you're to run like a scan on a web server and it says, oh, it's hosting something from like 1988, that's probably super old and super vulnerable because it's never been touched for like 20, 30 years. So when I say gather information, try to do that as much as possible. And Nmap, which is what we talked about last time in the networking portion, it helps you identify what's running on a server. So open ports that are open, Nmap will show you that. And yeah, so let's get into web app attacks. So basically, there is like a web app security project called OWASP, so the Open Web Application Security Project. Basically, this is almost like a community of some sort where like they basically will show, they'll read up on web application attacks that have happened to like enterprise, like people in enterprise, corporate networks, stuff like that. And they will basically identify the most common web attacks that happen every single year and make a list off of it. So the list that I made right here is just common ones you'll see for CPTC and also like CTFs you might do online. But every year they'll post the top 10 and you can kind of see like what are people like, what are adversaries using on a daily basis and what was like most popular that year. But we'll be talking about all of these for the most part today. And there's a lot more. And when we go into it, it's just like barely like scraping like the top of anything. So you can get very, very deep into it. And I can like talk to you guys more about that after. But yeah, let's get into it. Also, is there any questions so far? As like a little overview, but yeah. Yeah.
When you Nmap IP address, what does it actually do?
So Nmap basically, so do you remember like what a port is?
Yeah.
Okay. So basically Nmap, what it's doing is it's basically hitting every single port from like 1 to like 36,000, something like that. It'll try to hit every single port and see if it can establish a connection to it. If it does, it'll send you information about what it got from it, and then it'll output that to you. So if it finds a port that's open, it'll say, hey, this port's open. You can go investigate and see what it is. So basically it looks at every single port that's open on a server and tells you, hey, this is open. This is what's running on it. Yeah. Any other questions? Cool. All right. So before we even get into that, we need to talk about some things that are like really fundamental, which is a tool that you'll always use for web apps. It's called Burp Suite. Basically, it's a tool for web security testing, and it's like the Swiss Army knife. Everyone will always use it. And basically, what it's mainly used for is a proxy. And basically, for like the really simple term of what that is when you're like browsing the web, right? You like type in google.com, you hit enter, and it goes straight to Google, right? Well, Burp Suite, what it does is it acts like a middleman. So a proxy is like a middleman. Basically, imagine like I'm talking to you and someone else is relaying what I said. So if I say hi, you don't hear it, the person in the middle tells you I said it, right? So Burp Suite, basically when you hit google.com and hit enter, what it'll do is it'll take what you sent and be right in the middle and be like, okay, before I even send this, I'm gonna show you what's there and then send it out to google.com. So basically the reason why that's useful is when you hit google.com and hit enter, it'll show you like things about your request that you're sending to the web server. And that's really useful because just hitting like google.com and hitting enter, you can't see like all of like the verbose, like all the details that you can see in it, because you might be able to modify something and hit enter and it might do something weird. So that's why burp suite is really important. And on the bottom, the last bullet point, I kind of added some things you can do, which is like stuff we'll talk about. And I'll show you why burp suite is useful in a bit. Okay, so just some terminology that I want to like talk about when we're talking about web apps is a really important theory or like concept to do. It's called spidering. So basically, when you're doing an assessment on a website, what you want to do is you want to go, like, before you even try to do any exploits I'll talk about or vulnerabilities later, you want to get an idea of how the website works, right? Don't just jump in and be like, oh, I'm gonna try to hack into this thing. Get a good idea of like what this thing even is. So what I mean by that is go through all of the pages. So if it's like a website about like, on like patients, right? You can go through like each patient, you can go and see like the medical details, whatever you want. Go through all of them, be very diligent about looking through it, because your main goal is you need to identify what's normal so that when you start to attack it, you can see what's abnormal. If you just go and try to go and hack into something without knowing what its purpose even is, then you might just be like running into a wall thinking, oh yeah, this is working. Wait, oh, that's just how it's supposed to work in the first place. So spidering, all it really means is you're going to go on a website and just click through all the pages over and over and over again. And you can kind of see right here, they're using this test php.vulnweb.com, and these are like the pages they're clicking on. And you can see like folders within it that go like deeper and deeper into it. So that's what spidering is. All right. So the first thing is called directory brute forcing. Basically, so we mentioned spidering, right? You click on all the websites, you click on all the pages. You're trying to get an idea of what the website is. What if there's things on the website that you can't click on, you can't see, but it's actually being hosted online? That's what directory brute forcing is for. So basically what it is directory brute forcing is you use a tool that will basically use a word list of like common files that are like known on the web. So let's say like admin, there's like login, there's like pages like that where you'll see at the end of a URL. And basically the purpose of it is that if it's not visible to like the user just clicking on things, this might also find it. So basically you just run the tool and it'll try all these words and basically append it or put it at the end of the URL and try to see if that page exists. So you can see like right here, they have this IP address 172.31.1.5 and actually found these files right here. So about, blog, console, contact. Basically what it's doing is it's basically putting it at the end of that IP and trying to find a bunch of pages. And this is the one it found. And it uses like a word list of like common files that it can find. Does that make sense, everyone? Cool. All right, so the first web app attack is injection. So basically what injection is you can basically go and put your own code into a program and the program will interpret it and execute it. So there's two types of injection. There's SQL injection, which is like a database, and there's OS command injection, so operating system command injection. So let's get into SQL injection first. And just by raise your hands, have any of you heard of what SQL is before, or SQL? Okay, so basically, I kind of guessed that most people wouldn't know because I didn't know either. So SQL is basically, it's a query language. Basically what it's used for going and accessing what's in a database. So you have a database, let's say of like users and like patients or whatever, right? You need to go and like output on your website, like information about the user that you have. You use a database for that. You don't like go and manually do it all. Your database will hold all the information out for them and it'll just grab things from them in a query. And basically these SQL can go and like modify something, it can delete something, it can create new things, it can list things, do a lot of things. And I mentioned on the bottom, common things you can do is like find like even like login portals, right? You type in like your name and your password, right? How does it know to log you in? It tries to identify, oh, this is your name in a database, this is your password, both match, okay, I'm gonna log you in, right? You wouldn't want someone to type in your name and some random password and just logs in for you, right? That'd be bad. So databases go and do that for you. They can go identify like, oh, this username exists, this password matches this username, log them in. And we'll talk about that right now. Okay, so basically for SQL, this is kind of what it looks like on the top. So it's a query and it kind of makes sense because it's like in plain English. So to kind of give you an idea, I put a little like chart on the bottom and I'll explain what this is. So at the top, we see that this is the whole query. It says select ID from users where username equals some sort of username and password equals some sort of password. So basically what this is doing is it's gathering information from a table called users. So the whole table, the table called users is this whole entire thing right here. And basically within that table, there's a column right here called ID, right? So it's like 1, 2, 3. So within that column, you're going to see that there are rows for username and there's rows for password. Basically what it's doing is going to find, it's selecting the ID from this whole users table and trying to match where the username and the password match each other. So it's like going left to right here. Does that make sense? Any questions on that? I know that was really quickly. Yes, no?
So that's just like how data is like arranged in SQL, like that's it.
Yeah.
So if I was to look at like a database, just scroll through, then like would it also have like, sorry, would it also have like specified columns, or is that just like in the, like I just know, okay, like I wouldn't have like marks such as like ID, patient name, password, or something?
It could be whatever you want. So whoever created a database, you can have as many
Okay.
columns, rows as you want. But for like something like a login portal, so imagine logging into like your Fulton College, like the student login portal, whatever. It might have something like this where like there's a username, a password, an ID, and this is what's going to like kind of look like. So when you type in your username and password, it might be using a query, something like this, and this is how it'll validate who you are. So like it'll check your username, it'll check your password. If the both of them match, it'll log you in.
Oh,
Yeah.
When you had select ID from users where username equals this thing and password equals this thing, so would it actually go, like search for the, so if you have a login page and when you write the username and password, it goes to the database to check for it?
Yeah.
And like it will return the ID. So that's how the verification will work over here.
Yeah.
Like another example to like just give more examples. So like for you're probably wondering like what parameters we can have, like what are like some other rows and like columns we can have. So like for example, we have like Fullerton College like catalog, course catalog, right? So like if you think about that and you have to apply database for that, because they're not going to manually put in like all the courses, right? They're not going to like store it somewhere where you have to manually grab it every single time. Think of things that are like that are native to like all courses. So we have like professor names, right? Professor first name, professor last name, the CRN, the course number, the course name, the course like whatever it falls under, like CSEI or like engineering, like things like that. So things that are like applying to like every single course, they'll have like a what do you call it? like a
An entry in the
an entry in the table. So that's like another example beyond like login portals, because you know it helps to have more examples.
Yeah. Any questions? Okay, cool. Okay, so now you're probably wondering, okay, so how exactly do we abuse this, right? So let's look back at the query again, right? So we said it's selecting an ID from users where the username is whatever you typed in and the password is whatever your password you typed in, right? So what would happen if we just stuck a single quote at the end of the password? How many single quotes are there now at the end of the password? On the second one? 3. There's 3, right? So for people who aren't like, who don't do coding, basically what happens is these are usually called a string. And basically whatever is inside the single quotes will be interpreted as the password, whatever, right? But if it, remember, it's in between this. So it has to be between these two. If there's 3, it'll think that this extra one will throw an error because it's trying to think, okay, it's going to show nothing and another one. So it's going to throw an error. It's like, oh, this isn't a string. It's like an extra semicolon is there. Not semicolon, a single quote. So when that happens, the code breaks. And you're like, okay, well, what is that useful for? And we will talk about that in a second, because if it throws an error, that's actually really good for us because we will see in a second. Okay, so we get an error. Okay, now what, right? Who cares? Basically what you can do is you can trick the query to run something else after it if you use a single quote. So to give an example, you can see on the bottom right here, and I kind of color coded to make it a little bit easier, is we put, so the green is what we put in ourselves. and the black is whatever that was already there. So remember I told you password equals whatever you want inside the quotes. So basically what this is doing is we put a single quote in here and we say or 1 equals 1. Basically that's saying or true. And then these three little dashes is a comment. And in programming languages, comments basically say whatever else is after this, we're not going to execute it, we're not going to run it. So let's try to go and figure out what this is doing, right? So it's saying we're going to select the ID from users, what basically it's going to go to the column where the username equals whatever you type in. So I'll put Bryce, and password equals true. So basically it's going to go and interpret that as true and just basically throw everything in there. And I actually have a little bit of an example. Oh yeah, I basically just talked about that. But let me show you. Okay, I think that's, I hope that's still sharing. I think it is. Is that still sharing on Zoom? Okay, cool. Blah, blah, blah. All right. Let's go here. Okay. So this is kind of like what we showed last time. So it's saying there's a user ID. You can type in whatever you want and hit submit, right? So it's asking for an ID. IDs are usually numbers. So let's just type 1 and hit submit. Okay, it says ID 1 is first name, admin, surname, admin. Okay, let's try, oh no, 2. Okay, it's Gordon Brown, 3, 4. What do we want, right? Let's do what we said. Let's do what we said. Let's take a submit a single quote in there. Submit. Oh, we get a syntax error. It's saying that there is a MariaDB server version, blah, 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 blah. And it's saying there's a bunch of single quotes at the end of the line, which is perfect because that's basically what happened. So now we need to try to get this working somehow. And I mentioned that quotes are great for that because basically it'll say, whatever you want after this, just don't interpret it. The reason why it's throwing errors is because we put a syntax error in it and I was trying to interpret the rest of it. But if we can somehow make it work with this single quote, we can maybe do something malicious to it. So let's say we mentioned or 1 equals 1, so or true. Basically saying if the password is valid, log me in, which we don't know the password, right? Or true. So we don't know the password or we don't know the ID or anything like that. So just put true, so it'll always validate something. So let's do 1 equals 1. You can do 2 equals 2 or whatever you want. And let's try that now. It's still going to throw an error because it's still trying to interpret the rest of the code. So we need to comment it out, right? We need to comment out the rest so it doesn't read any of the rest of the query. So we can try like dashes. This doesn't work. And the reason why is because MariaDB, which is like multiple, there's multiple SQL servers. There's like Microsoft one, there's one called MySQL, there's MariaDB. So what we can do is go on Google and just type in MariaDB comment. Or we can type in, what is comments in MariaDB? Okay, it's a hashtag. So let's go back and put the hashtag in. Let's see if that works. Boom, it shows all of them. So the reason why I did that is because it's just interpreting, okay, show me the ID, right? It said it's going to select the ID and the first name and the surname, or just show me everything because I said it's just true, just show me everything. So that's really bad because could you imagine if you did that to a bank, you type in the username and the password and it just lists all of the username and all the passwords for everyone in a bank? That's terrible because now you just have access to every single person who basically has an account with that bank. So that's a really simple idea of SQL injection. Does anyone have any questions about that? Yeah.
What website you want right now?
Oh, this is like self-hosted. It's called Damn Vulnerable Web App. You guys can actually host it on your own Kali if you want. But I was just doing this right now just for like demonstration.
Yeah, it's not open to the internet or anything, so we're
Yeah.
hacking ourselves.
Yeah,
This would never happen in real life.
it would. It would.
Wherever there's
Yes.
like people, there is like a good amount of times that the developer didn't cover for this case, and then you can get it. Like, because the backend engineer has to actually take care of this and make sure that people cannot execute the you code and you look for these statements. Like if somebody is trying to mess with your SQL, first of all, if I am the one developing it, I wouldn't add the query to be like directly go in there and pass the input directly into SQL. So the SQL will say there will be another layer of application that will connect the front end with the database. So everything that goes to database will go through this another middle layer, and it will check in for this and make sure that these things don't.
It's the only way it must work.
No, there's a ton of ways. It's just like barely scraping like anything. Yeah.
But then, like, as Nasir said, this is a scenario where your front end is directly connected to a SQL.
A back end.
Like
Yep.
there's no inner engineering happening where you're like preventing for like, okay, well, user ID can not be at the rate symbols and stuff like that.
Yeah. So whoever is doing the back end would have to compensate for that. So like when you're doing stuff like if you're doing like back end, like databasing and stuff like that, you should like, even just like in general comps, like if you're doing anything where a user can type in something, you should always assume the user is going to do something absolutely stupid. So you need to go and always compensate for that. If someone's typing in their name, they should only type in characters. Even people with like single quotes in their name, like if they have like, or even like people who have like junior or like whatever, even that gets like tough too, because like, well, maybe I don't want a dot, maybe I don't want a single quote, stuff like that. It gets like really complicated. But for the most part, to like prevent stuff like this, you use things like parameterized queries. And basically what that means is that you want to go and make sure that whatever the user inputs, you don't want it to actually be interpreted as code. So parameterized queries, and you can probably look into that more later if you want to, but that's a great way to go make sure that people who are entering in code for SQL, like if they're typing in like user data, it's not being actually interpreted as code. That's the main problem, is that when I did this single quote or 1 = 1, it's really interpreting that as code and not as just normal user input.
I have a question. When you had the query in the beginning on the slide, it was select ID from the table where username equals username and password equals this. So when you write this a single quote, it means that that's where the original query ended that was done by the developer.
Yeah.
Now you're just replacing it with or true. So most of it, if somebody has taken a programming course, are you trying to like add an or statement in there, like this is true or this is true? If one of them is true, the whole statement is true.
Yeah. So a really good idea too, like a really good example is like for logins, right? So the reason why I mentioned the login is that imagine you know a username, right? If you guys had to guess a username for a website, what would you guess one would be?
Yes.
Guest,
Admin.
admin, root, stuff like that, right? So if you have an idea of what a username could be, basically remember the query is saying, I'm going to try to validate if this username is true and if this password is true. If both are true, log in, right? So if you say, okay, this username is admin and his password is nothing, right? So now the password is nothing. And then you also put or 1 = 1, which is true. So you're saying if the username is admin or the password is blank or true, then log in, right? And for or statements, it's going to pick the one that's true. So it's going to say, okay, the password is not empty. What's the next thing? 1 = 1. Oh, that's true. Log in. Does that make sense?
Why can't you just start true instead of 4 = 1?
I think you could. I actually don't know like Boolean statements on SQL that well, but
So just to add one thing here, like it is just like different forms of true. So some developer might have cached it in for checking for this, but there are other true statements that you can actually put in, like 2 = 2, or the true in MariaDB is like something like m is equal _ true or something, but there's something that you can add that is equivalent to true in the programming context.
yeah, I think you could even do something like or like A = A, and then so comparing the two strings together, that works too. So yeah, stuff like that.
But then it becomes like our responsibility to know. There's like, of course, like they're using MariaDB, some other company or some other
Yeah.
field might be using some other database. So like that's on us to figure out like what they're using.
Exactly. That's why when I said getting errors is a gold mine, if that didn't show an error, how would we ever know which database that is? We don't. So a lot of like web app security, like pen testing, is trial and error. You'll like want to bang your head against stuff a lot of times because companies that do this, they won't show you errors unless you're lucky. You're like, oh, thank God they did. But what you do is it's just trial and error. You're like, okay, this one, like this comment didn't work. Let me try a different one. Let me try a different server's way of doing comments. And then if you do find it, you're like, oh, this is Microsoft's one. This is MariaDB. This is whatever. So that's how you can go and validate stuff like that. But for the most part, like databases, the way they work, all of it acts the same way for the most part, just like different syntax. Okay, that makes sense. All right, cool. That's probably the most complicated thing on here for the most part, but yeah, it's like a really classic one. So yeah. All right, this one's a lot easier. So OS command injection, basically it's the same premise. You're trying to go and inject code into something. You'll notice that's like the repeating theme for a lot of these things. But basically for the most part is that there's an application that is running like OS commands. So it's like ping, ls, stuff like that, things you learn in like the Linux class. And basically what you can do is you can try to inject your own commands into it and try to change the way it's working. And so this arises again because you guys are like whoever is making the application is not going and validating what their user is inputting in, which is terrible. So you should only limit what the users can do to a certain extent. And we will show that right now. Okay, and actually I can do that right here too. So there is command injection. Okay, cool. So it's telling me I can ping a device, right? So what does anyone know what ping does? Yes.
Oh, that's better.
Yeah. You know what ping does?
I think it sends packets and receives packets.
Yep.
to the IP.
Yeah. Oh, do you have a question too?
Oh, no.
Okay, yeah. Okay, so I actually don't know if this can hit the internet, so I'm just gonna ping myself. Does anyone know what pinging yourself looks like?
It was on the network. You see.
Zero.
No.
1 to, where's the hint? 1 to 7. It's like in every computer mean that you see, maybe it might be written 1 to 7.
Does anyone know what it is?
Like there's been a lot of famous security memes on it. Like, there's nothing like
192.127.1.1.
yeah, but not the 192.
Yeah, it's 127.0.0.1 or localhost.
Oh, okay.
Okay, so if we do that, hit submit, it's gonna hang for a little bit, and then
Point.
Or do you?
No.
I'm sorry.
oh wait, oh,
It worked, but
it worked for some reason.
Okay.
Okay, and if this doesn't look familiar to you, I can just open up a terminal and do this as well. It's also really tiny. Hold on. Boom. Okay. Okay, let's stop it.
I think if you like ping 0, it does the same thing.
Ping 0, really?
What
I
the
never
heck?
knew
I
that.
didn't know that.
I did not know that. The more you know. Yeah, we can try that too. Let's just type 0 and see what happens. Remember, being a hacker is just about being curious. It worked. Okay, cool. The more you know.
Shit, what the heck?
I did not know that. Okay, so
But
Move back.
if when we just ping ourselves, just keep scrolling, does that mean like we're pinging continuously?
if you don't stop it, yeah, it's going just back and forth, back and forth, back and forth. Yeah.
But
So-
in this backend, I think it's doing like count 4. So you can see that it sent only 4 packets max. So it's specified to only do 4. Well, in this one, we had to manually stop it. In the backend for the website, it's probably doing -C4,
Okay.
which is count.
Yeah. Oops. Yeah, if we do like, yeah, -C count. Don't worry about what you just saw. I was coping a long time ago, aka 2 days ago. But yeah, so if we do ping -C4 and then 127.0.0.1, this will basically be the same exact output as what we saw over here. So we have an idea of what this is doing. It's running this command 4 times and that's it, right? Well, we're hackers, so let's say that we don't want to do something. Let's just like type gibberish in and hit submit. Okay, it does nothing. Okay, cool. All right, what if does anyone know how to do other commands after another, like one command? So if I did this, yeah, so yeah, we can try piping it, right? So let's say we do this and do like ls, right? Whoa, that's weird, right? So that means that we basically went and just ran code after the own. So they just had this code running, but we're like, oh, let's just stick something after it, right? So we can do whatever we want after this now. And we don't have to just use pipe. We can do like a single quote because that'll basically say run this code and then run that one after. So we can do this in ls. We can do like the whole like ls LAH and get like more output out of it. So now we basically took an application that's supposed to be doing something and we injected our own code after it to be basically doing something after it. Yeah.
So then I'm getting that, like the common factor in these vulnerabilities is that our input is being read as code.
Yep.
It's allowing us.
Exactly. Yeah, exactly it. And the whole point of it is you can either like from this, you can do a lot with it. You can probably get like what I mentioned, a shell, so you can get access to the actual server. You can try to get data. So like, oh, like what's this like help thing, right? Or what's this index.php? We can do, because this is basically what we're doing is when we run this code, we're running it in the directory it's being hosted in. So if we do pwd, which is like print working directory, you can see we're in this right now. We're in var HTML vulnerabilities exec. So what if we wanted to see what's in this index.php file? How do you
Yeah, just.
cat? Yeah. So we can do like, oops. Why is it not hello? Uh-oh,
Oh, your Kelly froze.
my Cali froze. Oh well. So if you're to do cat on it, it would go and basically just show I'm the newbie host. Gosh. All right, let me start sharing again. Hopefully it doesn't go down again. Okay, cool. All right, does anyone have questions on that?
Actually, I did. So
Yeah.
kind of following off from the NCAT thing, because if I'm not wrong, when we were doing Bandit, the Nmath level required you to Nmath find the port which was not echoing and then connect through it. But then didn't you also have to, like, on your own end, go to that port and send back a signal?
I have no idea. I didn't do that, so I don't know.
Yeah, you have, because you just have to check out of all the ports, which one wasn't like printing out echo again and again. And
Right.
You used to have netcat, if I'm not wrong.
Yeah,
so you
yeah,
can
yeah.
connect to it. Yeah, that's what Bryce was mentioning, if it's like some weird port where the developer is using their own thing, that's what you use netcat to evaluate it. a little bit.
Okay,
So like when you connected to it, you type something and it echoed it back to you, right?
right.
Yeah, so yeah, basically on the back end of that, it's just running something where like when you print something, it'll take that input and then it'll echo it back to you. And so sometimes if they programmed it correctly, you could abuse that in some way, but I'm pretty sure Bandit would secure that in some way. But if you knew that it was, if you were like, oh, maybe it's vulnerable and you tested that, you could probably exploit it in some way to like maybe run another command or do something else with echo and abuse it.
Because I think I was like in like the 18th level, and actually ended up finding a file which had like passwords of like 22, 23, and 24.
Oh, okay, yeah. Yeah, like, there definitely could be a port hosting something where you can go and use Netcat and type in things, and you might be able to run commands that way. So yeah, it definitely could be something that you can do. But yeah, any other questions on this? Cool, okay. That's basically what we just did, so yeah. All right, so another one that you might see, and this one's pretty simple, is broken authentication. So when you go and log into things, it has to authenticate who you are. And basically people who go and build out this authentication mechanism might basically make it and it will be like insecure in a way. So the common ways that'll be insecure is that there's like 4 ways you can attack it. There's like brute force attacks. There's session cookies. So people know what a cookie is. Have you ever went to a website and it's like, oh, accept all cookies. Yeah, have you guys seen that before?
Yeah,
Do you guys know what it is?
no, but I think.
Yeah, yeah, I hate it too. Yeah, so basically cookies in a really simple way is it's a way to track what a user is doing in your own little session, right? So imagine like you're on like Twitter or something and you're doing whatever you want and then you click out of the tab and then you're like, okay, let me go back to like 10 minutes later and you go back in. Would you guys want to log back in every single time you log out of Twitter? Or would you want it to be like, oh, it remembers where you are and what you were doing, right? So you'd probably want it to be like more user-friendly and like more like, I guess like of ease. So what cookies do is they basically track what you're doing in your session and they'll basically save it to your web browser. So it tracks your login and then it also tracks like what you're doing for the most part. So when it says like, oh, do you want to accept all of it? They might also be like doing like ads, like what are you clicking on so that they can go and use that to like show you ads or sell your information, whatever. So there might be weak session cookies. And these are like usually like strings of text and numbers. And most of the time it's really complicated and like they use like algorithms to go or like encoding to go and make it so that each session is unique to you because you wouldn't want to have someone else's session, right? Which is definitely possible. But you'd want it to be like obscure to the point or like abstracted to the point where people can't go and like guess your session. There is times where people can actually guess your session. So imagine like it's like A, B, C, D, E, F, G, and then a bunch of text, right? You can predict that A, B, C, D, E, F, G is always consistent. So now the only thing you can worry about is like the rest of the text. So that's what I mean by weak session cookies. There's weak credentials. So if you logged in, typed in admin and admin, that's weak credentials. And then validation flaws. There might be ways where you can type in something and it just validates you for some reason. And we'll talk about that a little bit. Okay, this is basically what I talked about. But the validation flaws is something I want to talk about because it's kind of scary and something that I used to not think about until like a year or two ago. But imagine you're creating an account, right? And it's asking you to print in your username, right? We mentioned before that there's common names that you might see for websites. So we talk about guest, there's admin, there's root, there might be like administrator, stuff like that. So if we type in a username, we can guess that admin is probably taken, right? If we type in admin, say username has been taken or whatever, right? Well, what if we just put a space and then admin? Will that work? Maybe it will, right? So if the database is correct, maybe it'll interpret that space and admin, maybe it won't. And it'll just think, oh, that's just the admin user. There's no space, just forget about it. It just says admin. Maybe they're only validating characters and not like white space. They're not validating like spaces and stuff like that. So that's where validation flaws might come in. And you can probably maybe log into a user with admin if you put space in front of it. But this is for the most part what broken authentication is, kind of simple. Just like brute force attacks, which is like you can type in a username and password and just keep guessing it over and over again. And there's tools I'm happy to do that for you. And then we talk about weak credentials and social cookies already. Any questions on that? It's really just high level. Okay, cool. Now for more complicated one, there's XXE, which is XML external entity. And before we even get about that, we need to talk about what is XML, right? And people might think like, oh, like Excel documents, stuff like that, right? Basically, it's a markup language for organizing human readable data format. So basically, what the hell does that mean? It basically is a way for a system to like structure out documents. And it uses like tags, almost like HTML, if you guys have used HTML, and it has elements within those. And basically what XXE is that within this XML document, there is a thing that basically can go and parse through it and find these things called external entities. And basically what external entities are is it'll go and within the XML, it'll find documents referenced outside of it. So think of like files, right? So we can possibly go and use that external entity, so the thing that it's referencing, and maybe tell it to go and fetch a different file. And I hate definitions. I just like seeing things. So I'm a visual learner. So I have example scenario for you guys. So basically, let's assume that we have an XML document and it references an external entity. Maybe it even doesn't, right? So basically what we can do is we can manipulate the XML to put our own input in there, right? Remember, the whole concept of web applications and abusing it is if there's input that we can do, we can probably abuse it some way. So let's see how we can do that. So let's assume we're on a website and we see this, right? We see like a bug bounty report system. So we can say, oh, we can put like a title for our exploit. We can put the CWE, CVSS score, whatever. That doesn't really matter. Let's just like put numbers in and see what happens, right? So we type in numbers, we type in a title, whatever. And on the bottom, it prints out this. It says, if the DB were ready, this is what you would see, right? You'd see the title, CWE, a score, and a reward. So you get $1 million. That'd be sick. Okay, so I mentioned Burp Suite, right? Burp Suite is a way for basically you can send a request to a web application and it'll show you like before you send it out what you're sending out and what the response will be. So before we send it out, this is what it looks like inside. So it's saying that there's it's XML, which is good because we mentioned it's XXE, XML. And this is what's in it. It says there's a title, COE, the number we put in, and there's $1 million reward. So we mentioned that XXE mentions an external entity. So basically these are like files. What we can do is we can stick our own thing in there. So within Burp, before it sends it out, I told you that we can use that proxy to go and put our own things in. So you guys can ignore for the most part, like this doc type element thing. This right here, this entity is what's important. Basically, this XXE is like an object. So basically, this is what the value of this right here is going to be. And this is the file thing is what's going to be inside this object. So basically, we're mentioning Etsy password. Does anyone remember what Etsy password is on Linux? Yes, no? Okay, cool. Okay. I will do it right now. Hold on. Also, I'll mention why Etsy password is mentioned all the time. The reason why it's mentioned so much is it's a file we can always read no matter who we are. So if we're trying to go and like read files, which is something we commonly do for like injection, we want to make sure we can go and validate some way, right? We don't want to just like instantly go to like a passwords file because like, oh, what if we can't even read that? And we're like, oh, it doesn't work. Let's just go somewhere else. We always want to validate like with some file that we can have for certain that it works. So Etsy password or like other things like that too also work, but that's like a really like classic one that people go to. So let me open up Kali. Hopefully it loads. Cool. Okay, so if we type cat Etsy password, it's this. It shows all of the users that are on here. I know it's like cropped out a little bit, so I'll do like that. It shows all of the users that are on the host. So it's just Kali. But all of like the services and stuff like that too, that's what's also there. Okay.
can't change one, the readability
For this,
on password. Yeah.
you can, but if you look at it, so notice that every single, so the owner, the group, and everyone else also has read to it. So no matter who you are, they can read this file, which is good, right?
But if you change it.
Yeah, if you change it, but for the most part, no one would ever change that because, huh?
Oh, that's.
Yeah, the reason why is that it actually, if you were to change that, it actually might break the way Linux authenticates you because it also references that too. Yeah, so you probably just wouldn't want to ever touch that.
Wait, so when you say these are the users on your computer, as in like those are everything that's running currently on your computer?
No, so basically, remember we talked about last time, there's like services that run on Linux. So basically, when services run, technically they'll have a user with it too. So we can see these like Postgres, polls, all these things. Anything where this, like you see what this is 1000, this is like your user ID on the left, and this is the group ID on the right. So basically anything under 1000 is usually like services or like users that the system owns. So it's like basically things that came with the system. Everything that's over 1000 is like actual users that are on it.
Okay.
Yeah. Okay. Zoom's still going. Cool. All right. So basically we stick that in. So we enter our own entity and reference a file that we want in it. So remember that when we typed in title, it was just title, right? So it printed out title right there. So if we stick in, if we mention an entity called XXE and we're telling it to grab entity password, what do you think is going to be in title instead? Any guesses?
The password.
Like the file?
Yeah.
Yeah, there it is. It's right there. So now the title is just the whole file itself. So that's crazy because now, just like last time, what if we can go and read like passwords.txt, database.php, something like that? That's deadly because now we can go and read files that are on the system. So this one's interesting because you basically can't run code, but you can read files on there. So basically now you can go and like try to find like what files are interesting to you. And you're probably wondering, how can you identify that? You can't sometimes. You just have to take like a good guess. Like if it's running a Python application, you can like Google like what's a common like scheme for people who do like applications on Python. There might be like an app.py or init.py, stuff like that. Basically, you Google around, find out how it's being structured, and maybe you can find something in there. Yeah.
So would this be more likely to encounter than the other vulnerabilities?
I'd say yeah, because for the most part, like it's kind of like rare to see like XXC out in the open, but there's like, I mentioned like the OWASP top 10, so you can reference that to see like what's most like prominent. This one you don't see as much, but you can still definitely find it somewhere.
Like, I guess my question is, just because it does require less permissions, does it go more like under the radar? If that kind of makes sense.
It depends. It's like highly, it just, yeah, it just depends. Yeah.
Sorry,
Yeah.
to add in the headers, did you use person?
Yep.
to do that? Okay.
Yeah. Yeah, so you can see on the top left, it says like response. There's another window on the left that says request. And I can actually show you that real quick. So I actually have Burp Suite open right here. And this is already on your Cal. If you were to go here and type in burp, it's right here. You can open it up. And this is super tiny. So let me, holy crap, I can't even read. Blah, blah, blah. That's settings right there? I can't even tell. Oh yeah, it is. I think it's gigantic. Oh yes, I can see now. Can you guys all see?
Yes.
Cool. Okay. So basically I mentioned this proxy thing, right? So you can basically open a browser. We can type in localhost and admin and password, very secure. And then if we go here to, let's make this bigger too. And full screen it. So let's go to command injection again. So we were to type in like 127, oops. We hit submit, and then nothing happens, right? It's just like same old, same old. But if we were to go back here and intercept it, so basically we're saying get in the middle of it before it sends it over, you'll see that it will automatically pop up when I type this in again. So hit submit. And then this thing pops up and it's super tiny again. Why is it tiny? Hold on. Why is it tiny? Oh, maybe I have to do blood. Where is it? Sorry. Nope. It's somewhere. They changed this. I have no idea where it is anymore. Huh? Okay. Anyways, yeah. So you can kind of see like, this is the request. This is like what it's going to send out. And you can maybe see it's like super tiny. It says right here, the IP is 127.0.0.1, and then it says submit. So if we were to hit forward, it's basically saying, okay, whatever's in here, just submit it. It'll go and forward it. And if we go back, it does it again. Also, it can probably make more sense if I do this. Hold on. Oops. Yeah, let's do blah, blah, blah. Let's get rid of this. Okay. Oops. Okay. Turn it off again, and then do, let's just type whatever we want, right? And then hit submit. You can see on the bottom, it's a little blah, blah, blah thing. So we can actually change it right here so that before it sends it over, it's going to put this in instead. You can forward it, and then you'll see that it sends that instead. So you can see how you can like manipulate things before you send it over, which is really, really cool because we didn't see that whole submit thing before on here, but maybe we can put like blank and it does something weird. That's like the whole thing. It's just like curiosity is changing things around and seeing how it interacts. But yeah, that's burp for the most part. Right. Broken access control. Basically what that is that there's like rules and like barriers that are made for users to access and not access. And this is like really, really simple. So basically, the whole point of like broken access control is like you should limit what they can access, right? But broken access control is you can access things you're not supposed to be able to. And it can be as simple as this. So a really common one for access control is something called IDOR. And it sounds really scary, but trust me, it's actually really simple. So it stands for insecure direct object reference. Basically what that means is that you can reference a internal object and it doesn't authenticate who you are, or it doesn't authenticate like what you're doing. So have you guys ever like went into the website and it says like something username equals like 123 or something like that? Like it might say like this at the end of it. Have you ever seen that before on your website? Maybe. Well, maybe not because like kind of just ignore it. But basically like when you log in sometimes it might say like, oh, your user ID is 123 or whatever, right? Well, what if you're to change that, right? So you say, okay, this is my username is 123. But what if I were to change it to 456? You would think, okay, if I hit enter, it should say like access denied or something like that, right? IDOR basically means that your ID is 123, but let's say mine is 456. I would trust whoever made the website has proper access controls, basically say that only 123 should be able to access 123. They should be able to access anything else. But if they don't have proper access controls, so they're broken, they can basically go and type in whatever they want for this ID. And also this ID is known as a parameter. So if you see like question mark ID equals or question mark something equals, that's a parameter. So whatever is there in between this question mark and this equal sign is known as a parameter. So if the parameter, we can change the numbers to like 456, maybe 1 or 0, because 1 or 0 is usually like admin or root. Maybe we can go and log in as them. Maybe we can access their session. So that's broken access control. Super easy. You can just go and try that out and see if it works. I have friends who have like just tried that on like random things, like during like hacking competitions, whatever, and got into things. So it's like super simple. Any questions on that? Pretty simple. Cool. All right. Next one is cross-site scripting. So basically what it is you're injecting malicious code or scripts into a website, and it gets usually executed by other users who visit the website. So basically something that's funny is that like a long time ago, like when people still used to use MySpace, basically you can put like, or like even like Tumblr and things like that, right? You can go and like stick whatever you want in there, and like Tumblr, like especially you can like make your own code, make it all pretty and stuff like that. And what was really funny on Facebook is that, I mean, not Facebook, like MySpace, is that MySpace was kind of like Tumblr, where you can go and like have your own like music, you can add your own stuff. It was like trying to be like cool, where you can just like make it like your own thing. But what people can do is that they can inject malicious code and scripts into it. And so what someone thought was funny is that what if they did that and it like spread across people? So they actually used this thing to go basically make it so that every time they clicked on their page, it would post on their own and make people go to their own site. So they make everyone go to their own page because they stuck malicious code in their own MySpace thing. And when people clicked it, it would be executed by the user who clicked on it. So it's like a big spread of stuff. And we'll talk about that in a second. First, there's 3 types of XSS. I'm not going to mention the last one, but I just wanted there as a reference. But the main 2 that you'll see is stored and reflected. It's basically stored, so I just mentioned, right? Imagine you have like a blog or Tumblr or whatever. Every single time you go to it, the content's going to be there, right? Imagine you had a post that said hello. Every single time you go to your Tumblr or MySpace or Facebook, whatever, it's going to say hello. It's there. So basically, stored means that if you were to go and inject code into something, it'll stay in the website itself. So every time you browse to it, it'll keep staying there. Reflected basically means that once you go and inject this code, it'll only be ran when like a user clicks on something. It won't be stored in there. It's just whenever someone clicks on it, it'll show up on something. Does that make sense? Kind of at a high level. Okay, so let me explain basically what that looks like. So let's imagine that we have like a website where you can have like comments on things, right? So let's say like every single time you comment on something, you can put like, oh, like, hey, check out my cool website or whatever, right? And when you hit submit, it'll like post that out somewhere on the page. It'll say, oh yeah, check out my cool website. And actually I can show you that here. I think they have one. Yeah, they do. Okay, let's talk about reflected. And let's close this because I don't need it. Where is, oh, there, cool. Huh? Huh? Oh. Okay, cool. So we can say, okay, what is my name? My name is Bryce, all caps. So it's saying hello, Bryce, right? It's being reflected out to us. The moment we hit click, when we click submit, it's being reflected back to the page of us. So if we type whatever we want here, it's coming back to us, right? So we mentioned that we can go and input malicious code into here. And since basically for the most part, this cross-site scripting thing, the main thing it refers to is like HTML and JavaScript. So for JavaScript, we can basically put like scripting tags and that looks like this, and then whatever we want. Basically, it'll basically run that as code. So if this thing were to interpret this, it'll actually just run that as code. But a really common classic one for cross-site scripting is there's a thing called alert. So basically what will happen is if we put this alert, if we hit submit, it'll pop up a little big message box and say, like, hello, whatever you want on there. So if we were to do script, and then we do this like alert function, and then we can put whatever we want, like hello, smiley face, or like whatever we want there. I hope that is actually, I'm scared I won't interpret properly. And then we close it out. If we hit submit, it'll pop up a little box like that saying hello. So it actually interpreted our code and ran it. And you're probably wondering like, okay, that doesn't seem like really useful. Usually when you see like cross-site scripting, you should consider like low findings because like it's hard to show impact because when you're doing penetration testing, the main thing you need to show is like how is this impactful to our client, right? The main thing you can do with that is I mentioned like session cookies, right? Like cookies. What you can do is imagine like you were to make like a malicious email to someone and you say, hey, click this link. And then like within it, you have like the little script thing in it. What you can do is like you can actually have someone click it and then have it send the cookie of your own session back to them. So now they can get your session and use it and act like they're you basically. So that's pretty scary. The other one is stored. It's basically the same thing, but you can see how I mentioned before for stored XSS, it's basically whatever you type in will be stored on the site. So you can see there's already one comment saying, oh, name, test, whatever. So if you do it, whatever here and hit sign guestbook, it's being stored there, right? So what if we were to put the same thing again? Oops, I hope the internet didn't die or what? Okay, I just can't. Okay. Oh, it's limiting how many characters you can put in. So that's why I was like, oh, I thought the internet died. So let's try this again. Say hello. And we hit sign guestbook. So now it's saying hello. And then if we were to like refresh it, it keeps showing again and again and again. Because now it's stored on there. Rather than just seeing it once because it got reflected back to us, it's always on there. So now whenever someone clicks on the site, it's just gonna keep saying hello, 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 hello. And that was like the MySpace Tumblr thing I mentioned. Is that if anyone ever hit your website or whatever, it would just keep showing hello or whatever you want in there. And you can put like malicious stuff in there. But yeah, that is cross-site scripting. Any questions on that? All right, cool.
It's okay. So So in a very high level explanation is just when there are no like backend security checks. So whatever you execute, like you executed a statement like an HTML code.
Yep.
So it's a code.
Yeah, exactly. It's interpreting like our HTML or JavaScript as actual code. Yeah.
But how
Yeah.
Sorry.
So-
No, go ahead.
Yeah.
So that help message will appear on the website with just one user uses it, or it's when every.
When any person accesses that website, it'll always keep showing that.
Okay.
That's stored. Yeah.
How?
How?
Yeah.
How
Like you passed it, so now it's just pasted on the. like,
Yeah.
As the actual code for the.
Exactly. Yeah. So I posted as a comment on there, and the comment is storing it, right? So that page is storing all of the comments on there. So whenever someone clicks on it, it'll say, "Oh, I'm going to interpret that code. I'm going to interpret that code," because it's a comment on the page. It's stored on the page now.
Okay.
No, it's already 4:16. Okay. Any questions? Cool. Okay. And like another thing is like just like for all these things, it's just basically like sanity checking what users can input. Users probably shouldn't be able to input like left arrow script, right arrow. You should probably like blacklist those or like deny list those at all. Like don't ever like have these things in there, and like try to limit what the users can do. So like obviously they didn't do that because it's vulnerable on purpose, but those are like things like that. Or even like you can try to like escape it, stuff like that. I guess a little like more complex, but yeah. Any questions? All right, cool. So this is probably like the most important slide, and it's vulnerable service versions, because you'll probably see this on a tryout hint. But basically what it is that let's say that you do an Nmap scan, right? So Nmap just goes and scans ports, and it tells you what version it is, what's running on there. So what if you go and do an Nmap scan and you see port 80 and it says like there's some website running and it's from like 1989, right? That's like super old. What we can do is try to Google, is there an exploit for this? Did some security researcher like find a way to exploit this and publish it online for like security purposes, saying, hey, you should fix this thing, whatever. We can go and search and then just run something and maybe get access to it. We don't have to know anything technical, just run their code, boom, we get access. So there's basically two ways you can do that for like the most part. There's a website called ExploitDB. ExploitDB is basically a database of just known exploits that security researchers can go and publish to. And it's like very reputable. So if you find something on ExploitDB, it's basically a good way to validate, oh, this is a service that can be vulnerable. The other thing is there's Searchsploit, which is just a command line equivalent. So if you wanted to stay on Kali and stay on your terminal, Searchsploit is basically just searching through ExploitDB, same thing. But yeah, so basically on top of that, don't let your search just be ExploitDB or a Searchsploit. You should Google a ton. So if you find something that's interesting, like you find out that it's running like Java in the backend, it's running Python, it's running something, you should go and search that up. If you find out it's running like Java from like 2000, maybe the web application itself isn't vulnerable, but the thing that's running it is vulnerable, like the Java application. Maybe you can go and abuse that somehow. So you should always go and Google like not only the application itself, so what the application is, but also what's running the application. Is it running Python, Java, whatever? And there's a great resource for that. So if you ever find like applications or like applications, like programming languages that are running it, frameworks, stuff like that, you should always go to the site called Hacktricks. It's like a great website. There's a ton of information there. This is like the holy grail of like what you should be looking at. I reference this like every single time I try to hack something. So you should check out Hacktricks because it's just a huge collection of like resources and just knowledge of stuff like that. And I just mentioned that too. Underlying technology, also Google it too, because you might find out the application itself isn't vulnerable, but what's running it is.
I think Hacktricks was blocked on the school network because I actually like was doing a box and I tried hitting it, but I couldn't access it. So yeah, just go like look at that at home, but it's blocked on the school network.
Yeah. Any questions on that? It's pretty simple. Basically, find something, search it up, see if there's an exploit, run it, done. Cool. Cool. Okay. Oh, I clicked on it. I'm gonna get sued. Just kidding. Okay. Oh. All right, cool. Okay, another one. So path traversal. So basically what path traversal is, or directory traversal, is it's a way to go and access files or directories that weren't supposed to be accessed. So basically the way this is done is by you try to escape out of where it's trying to access files. So basically remember that web applications, basically all it is it's hosting a bunch of files, right? So when you see like an app, like a web page, if you see like your login page, these are all just files being hosted by a web application. What if you can go and try to get out of that? Remember that Linux has like a file hierarchy, right? So it goes from like the top, the root, and goes all the way down. So what if we're all the way on the bottom and we can go up the hierarchy and try to get somewhere else? That's what path traversal is. And something that's interesting is there's another thing. I'll get the file up. Okay, put that slide in the wrong one on accident. There's also file inclusion. Basically, path traversal and file inclusion are basically the same exact thing, except one only reads files. The other one loads and actually executes files too. So LFI, local file inclusion, and RFI, these can actually execute files. So if you had like PHP, if you had like programming languages that can run code, LFI and RFI can actually run code. Path traversal can only read a file. So that's the main difference. And LFI just means you can load something locally. So you can only access files locally on the actual server. RFI means you can access something outside of it. So imagine like you're trying to like access your own files via the server. That's RFI, which is kind of like niche, but LFI is the one you'll see a lot. So I have an example for this. Basically, let's say that you are doing a pen test, you do an nmap scan, and you find on port 80, there's a website and it's hosting this thing called Elastics, right? The only thing you see is a login portal, username and password, right? But when you're doing the nmap scan, it tells you it's Elastics 2.2.0, okay? You Google it and you find there is an exploit, Elastics 2.2.0, graph.php, local file inclusion. Like, oh, I've heard that, Bryce said that in the lecture. So you go and look into it and you ignore all this stuff that, oh, whatever. The important part is this right here. Basically for local and file inclusion, remember that we're trying to go up. We're trying to go up the hierarchy, right? Because we don't know where we are. We don't know where this publication is hosting all the files. So does anyone remember how to go up a hierarchy, or like up in Linux? Like if you're like all the way down, like a bunch of folders, how do you go back up? Does anyone remember? Yeah, cd dot. So if you want to go up more, you just do //////. Basically, you can see a ton of ///////. So basically going all the way up the hierarchy because it has no idea where it is. And then it's hitting this etsyantportal.com. And that's something that's being hosted by the server. And so when we hit that, we see a configuration file. And what do you see in there? Username and passwords for things, right? So basically, we were able to go and find an exploit in here and get a username and password. So maybe this can log us into the actual portal. Maybe this can log us into a user. This can do a lot of things. You can go and basically try to access files with this. And that's what local file inclusion is. Basically, you find a file being hosted, you can basically try to escape out of it. That makes sense? Any questions on that? All right, I'm gonna go back to this one because I put on the wrong one. Something else you can do is you can upload files to things. So let's say that you upload a file and it's like, you go to the website and it's like, oh, you can upload a picture, right? So you upload a PNG, JPEG, whatever you want. Well, what if you uploaded like a PHP file and said, oh yeah, this is my picture of me, I'm a PHP file, whatever. And it's trying to run as code. What you can do is that you can make the PHP file like malicious code. So you can have it like run something. You can have it like connect back to your computer. Yes. Huh? PHP is basically, it's a web application. It's like a web programming language. And what? Yeah. Yeah, so like PHP ASPX is basically like web programming languages. So it's typically what's being ran in the backend. So you'll basically see a PHP ASPX. There might be like Python, stuff like that too. But ASPX is like more like a Windows thing. PHP is like something you'll see on Linux a lot. And they're just programming languages that run on the backend, if anyone had questions on that. But basically, for the most part, if you see like something running PHP or ASPX, something like that, what you can do is that you can upload a file that's instead of like a picture of you, if you're like, oh, upload a picture, you can upload PHP file and have it run the code in it. And if you have no idea how to run, like write PHP, like I do, you can just type in like malicious PHP file and then like upload it and see if you can like access it somehow. So the main thing is that you need to be able to, you need to know where the file is being located so that you can go and execute it. Because remember that when you navigate to a file, you can execute the file as well. So that's file upload. It's kind of simple. Any questions on that? Okay. So we have two more. I know it's a lot. So the second to last one is SSRF. So it's server-side request forgery. Basically what this is doing is that you're basically tricking the server to go and access things that it's not supposed to. And usually you're trying to access internal or external things, right? So I'll give a quick example on that. So let's imagine that you go on a website and you see this thing and it's a file scanner, right? It says specify the URL. So you can just type in whatever you want, right? So let's imagine you type something in and it just shows the URL of what's being hosted on it. And let's say that during like your Nmap scan of the server, you also see this port 5000 and it says 403 forbidden. 403 forbidden means that you don't have access to it, right? So that means that an admin can access it. Maybe it's firewalled off, something like that. So you externally can't access it. Well, that's kind of weird, right? So maybe we can use this file scanner that says you can just enter a URL to access things. Maybe we can trick it to access something internally to itself, right? So this port 5000 is something internal, right? It's the server is hosting this port, right? So what if we don't know what it looks like externally, but what if we can do it internally? So what if we put in right here port, or if we put 127001, right, which is locally, and we say port 5000, the one that we're trying to hit, right? To us externally, it said it was forbidden, but maybe we can trick it so that the file scanner that's also hosting, maybe we can tell it to hit itself on port 5000. And when we hit scan file, it gives us admin creds. I blurred out the creds, but basically what you're doing, all SSRF is, server-side request forgery, is that you can basically go and trick the server to go and access things internally that you're not supposed to see, or externally too. So maybe like you can access something that is on the network as well, and not just like only that server. Anyone have any questions on that? Yeah.
So server-side request forgery is like for applications where data and like running in a closed network and you get access to one of them. And then you can like access other devices from it, like which you cannot access outside. Is that what server-side request forgery?
Yeah, so you basically access the host itself. So you can access things on the host itself or things also in the internal network that the host is also on.
So if you get like if you compromise this one application, you can like literally access a lot of other.
You might be able to, yeah, yep. So basically we abuse that, this little application that seemed pretty like harmless, right? You can just go and specify a URL, hit scan, and it'll show you what's there. We abuse that by saying, hey, yeah, just show me something that you're hosting locally that I can't see, and now I can see it. So we are not supposed to be able to see that unless you're like on the actual machine, but we're not on the machine. We just told it to access something that was on it, and it just interpreted it and showed us it. Yeah.
So when we unmap, do we unmap the address of the actual website?
Yep. Yeah. Any questions on that? So for the most part, basically, you're trying to access things locally. So you're going to be using localhost or 127.0.0.1 or things that's also internal to the network. And you probably have to have internal access to even know what's there first. But then once you do, you can try to use this as like to pivot off of things. Any questions on that? Okay. I believe this is the last one. So SSTI, which is server-side template injection. Basically, what you can do is you can inject code into templates, and templates are basically a way. Actually, I'll just show you because I made it on the next slide because I was super confused at first about what templates are. So I kind of made it a little bit simpler for you guys. So on the right, you can see two pictures, right? They look pretty similar, right? What's the only difference? Basically, then.
Darling Anderson on the bottom one.
Yep. Yeah. So the names are different, right?
Yeah.
But everything else is the same. That's basically what a template is, right? If you want like things to be the same, but only some things change, that's what templates are for. So basically, templates basically look something like this, right? So on the left part, it says hi. This is like the static part. This is something we always want to see. So imagine our application, we just want to say hi and then your name, right? So the thing that's always going to stay the same is hi. That's going to be static. The part that we want to change is the username or your name. That's going to be the dynamic part. So that's going to be the template part that we're going to have in here. So basically, The dynamic part will usually be in curly braces, but it can also be different. So it can be like double curly braces, whatever. And basically, these are basically like template frameworks. And the most common one you'll see is something called Jinja. And Jinja is just a template framework. And usually it's basically like paired up with Python. So Python web servers will run Jinja if they have a template in there. So if you do like an Nmap scan and you see the Jinja, it's probably running a template framework. So you can maybe guess it's SSTI. So how is this vulnerable? So let's look at some code, and I try to make it as simple as possible because I can't even write templates, so I suck at coding. But let's say something like this. So we're saying a variable called template, and it's saying the static part is username, right? And then we're saying that right here, we want this dynamic part to be whatever the user is putting in. And it's going to render it, and it's going to say, this is the output. So it's saying, oh, username is me. So this is fine because what it's doing is it's just referencing whatever is already on the website. So this is controlled like by us, the developer. This is the only thing I ever show. There's no user input. The user can't input anything, so it's fine. We just told it to input, we told it to render whatever the username is of the user, and that's it. They can't ever change anything. We have it that hard coded in. Let's say we let them use user input. Let's say we let them go and enter in whatever they want. So now it's saying username plus whatever the user put in, and we'll render that. Okay, well, now how is this a problem? So let's assume that the user wants to test something malicious, right? We mentioned that for templates, they use these curly braces, right? So for templates, they can actually go and interpret like mathematics. So they can interpret math operations. And a really simple way to go and test templates is by doing math, just sending it math problems. So let's say for the user input, instead of saying, oh, I'm Bryce, right? And using the code as it's supposed to be intended to, let's say that we put double curly braces 7 times 7, double curly braces. Let's say I'm good at math, I know it's 49. Hopefully that wouldn't say 49 if we wanted to go and have this actually work properly, but let's say it does. If it renders 49, then we know that the template is actually reading that as actual code and not reading that as like just a name, right? So if we saw this 7 times 7, that means it just interpreted that as 7 times 7 as like literally. But if it saw,
Sorry.
Oh, no. Oh, but let's say that it said 49, that means that the template actually went and rendered that as code. So that now we can put whatever's in the curly braces and run code inside of it. So now the whole theme of this whole entire thing was we're trying to find ways to inject code into it and have the backend interpret that as code and basically use that to get onto the system, read files, do whatever. That's like the whole point of it. That kind of makes sense? So again, basically templates is just the one little part, like basically the template is if things are like the same on the website, but only one thing is changing, that's probably using a template. And we can, if it allows user input, we can stick curly braces and like math problems or whatever we want in there and see if it interprets it. If it interprets it, that means it's vulnerable to SSTI and we're injecting code into the template itself. Make sense? Any questions?
So when using math operations, it's just another way of checking if it's taking inputs.
Yep. Yeah. So simple things like that is just like validation because you don't want to just like go and jump the gun and be like, oh, I'm going to test like some crazy like code because you can make it super, super, super long.
Right.
You don't want to test it first, just like start small and be like, oh, it does work. And then start like expanding on from there.
So the first part, is that kind of time? Would that be like the part of, would that be considered for OSINT, kind of like gathering information, kind of vulnerabilities?
So OSINT is passive. So like it's passive reconnaissance. So that basically means that you're not like interacting with their server at all. You're only going and like searching at things from like a high level. You're not like actually interacting with things. So OSINT's like finding users who are working at a company, finding like their website, stuff like that. That's all OSINT. But like actually like going and interacting with their applications, that's not OSINT anymore.
OSINT is like, especially like the most important part is like, it's like publicly available information.
Oh.
Yeah.
Yeah.
The things
They're
on the
like, we're kind of like looking at things.
Exactly.
What we can find.
Yep. Good question. Any other questions? All right, cool. We're done. Oh, that was a lot. Okay, so now what? I mentioned that like the first day that we'll be referencing it a lot. So we talked about the initial recon, and now we initially compromised something. Let's assume that based off our exploits, we went and compromised something. So now the next part is we're going to skip establishing a foothold for now. And we're going to talk about escalating privileges. So basically, what is escalating privileges? Exactly how it sounds. So let's assume that we get onto a machine and we're just like a lousy little, like no privileged user. We can't really do much. We want to be able to go and do a lot more on the system. We want to be able to like to change things, access things that we can't be able to access. So we want to escalate our privileges, like, and be able to access things we shouldn't be able to access before. So yeah. Also, something to note too is if you do like a lot like CTFs, like hack the box, try to hack me, stuff like that, a common thing you'll see is things called boot to root. So root being the highest user on Linux, right? So root is like the highest user you can be. So boot to root is basically a way of like CTFs having it, you start the machine, you hack away and you get root at the end of it. That's not how real life works. And it's also not how CPTC or the tryouts might work. So if you get on a system, don't always expect to get root. That's not always the main idea of things. The main thing you need to do for CPTC, penetration testing, the real world, and also the tryouts is you need to show impact, right? Let's say that you get onto a machine and you don't get root, but you get access to all of the credit cards to the company. They won't care that you didn't get root. They're like, oh my God, you get all the credit cards? What the hell? It doesn't matter that you didn't get root. It's just you showed impact. You showed someone who is not ethical, who's an adversary, can go onto your website, get access to your database, and show all of the credit cards to your customers. That's terrible. That's the thing. You need to show impact. So if you feel like doing the tryouts or CPTC, or even if you get into like ethical hacking, that you can't get root, don't think, oh my God, I'm a terrible hacker. This must be something I'm doing wrong. Things are going to be hard into stone sometimes. So make sure that like you're just trying to show impact, just look around, try to find things. It's not always about getting root, because some people who are really into CTFs go into CPTC and try to do that. And that's not the goal all the time. I just wanted to like preface that a little bit. So yeah, I already mentioned what privilege escalation is. So it's a way of basically you get initial access and you're trying to get more privileges than you originally granted. And the main ways to do that is there's service exploits. So basically we mentioned before that things might be internal on the actual server that you can't see from outside that they're running. Maybe those are outdated and you can actually go and abuse those. So once you get access to those, you see even more stuff that's on the system. You can abuse those and escalate your privileges. Maybe it's running as a certain person and you can access you can get access to that user because they're running that service and exploit that. Maybe there's misconfigurations. This is really common. So let's say that there's like an IT administrator at your company and they're like, oh, I want to run updates like every single hour or something like that, right? And their code is sloppy and they're like, it's on everyone's computer and everyone can edit it. That's terrible because now someone can go on there and be like, oh yeah, I want to edit this. And now every single computer on there is going to run my own code. That's terrible. So that's like a misconfiguration. There's things called outdated kernels. So basically you can think of this as just like really old computers. So if the computer is old, it's going to be running an old kernel. And basically you can go and use that to go and exploit it. It's not as common, but you might see it. And the last thing, which is super common, is passive reuse. I mentioned before that when you're using all of these exploits, these web ones, you can access files. And the main thing is like, you want to try to get passwords out of it somehow. You want to try to get like useful information from it. So if you get access to the computer, so you get like a shell or you get access to it, you're going to try to find passwords because I can guarantee you that if you see a password somewhere, there's probably used somewhere else. And you probably think, oh, that would never happen in the world. It happens all the time. All the time it happens. So you should look for passwords a lot there. And because you might be able to go and find one, maybe the administrator uses that password. You never know. So yeah, I just mentioned what all of those are. And yeah, the last thing I wanted to mention is there's some tools you probably look into. You're probably wondering, so privilege escalation, you're probably wondering, how the hell do I know what to look for, right? How do I know what's vulnerable? How do I know like, what to look for? There's a tool called linpiece. Basically, it's a Linux script that can go and basically find automatically like privilege escalation vectors that it thinks it can find. And it'll like usually color code them in like red to show you like, oh, this is like most likely a way to go and escalate your privileges. And the nice thing too is that it's like categorized out. So it might find like configuration files, it might find outdated kernels, it might find passwords on its own, and it'll highlight those for you. And also it'll show you like within the category, hack tricks, which I mentioned before, that's blocked by the school. It'll show you like an article by it so that if you have no idea what it is, which is really common, you can click that and get more idea, like a more of like a good idea of like what you're working with. SQL map, SQL Map is basically a tool to automate SQL injection. So I mentioned before that when you do SQL injections, that was a very high level overview, the whole like commenting out things that might not work all the time. So SQL injection can go and actually run a crap ton of queries against it and see if it's vulnerable, like all automatically. So SQL Map is cool. We mentioned GoBuster, which is like the directory brute forcer. So it's basically ways to go and brute force the website and find files and directories. And then FUF is kind of like, I put that there just because, but if you want to read into it, it's a little more complicated, but it's basically used for fuzzing, which is essentially a way to go and like stick a bunch of inputs into something and see if the program reacts to it. And that's useful because I mentioned that when I put a single quote on SQL, what happened? It threw an error, right? So what you can do with FUF is you can try the same thing, but like use like percent signs, you can use at signs, you can do a bunch of things, it'll automatically do it for you and try to see like maybe the program is reacting a certain way. But yeah, that's probably a tool you won't use as much for CBTC right now, but LinPs is one for sure. I'd say look into that definitely because it'll help you a lot.
So when we put the SQL code, would that be considered fuzzing?
Yeah, well, fuzzing is more of like it's like doing a lot of it, but that technically is like kind of like fuzzing.
Like
Yeah,
at a very low level.
yeah, yeah. So you can like fuzz like manually, but this is like an automatic way of fuzzing.
Oh, okay.
Yeah,
So it has like a database. And everything.
it used to be like a word list. So it's like it's called a word list, but it's basically like a single quote, two single quotes, three single quotes. It's just a long list of like things that if things can break.
Right.
Yeah, exactly. Yeah. So that's it. Is there any questions at all? I know there's a crap ton of information. That's why we're going to post recording as soon as possible because yeah, it's a lot of information. Any questions? Yeah.
I'm gonna post right now.
Are those tools installed in Telegram?
So SQL Map and GoBuster and FUF are LinPs you can find on GitHub. Yeah. Any other questions? All right, yeah, we have like 19 minutes, so you can work on lab and homework. If you guys need any help or any questions, you can ask, but yeah.